Hello everyone, Mr. Skaggs here. Welcome to this brief video on graphing the solution set to a one variable inequality. Let's not waste any time, let's get right into it. So hopefully you have your graph paper notebook, handy dandy graph paper notebook, and are ready to get started learning some math. All right. So let's begin by recording today's date. This is the 27th in the top left corner. Giving this lesson or these notes a title. It's going to be graphing the solution set of a one variable inequality. Boom. Solution set. Sounds so fancy. But just like we were solving equations where the solution set was one value for a variable x that satisfied the equation, inequalities are a little bit different. Because you're comparing a variable to a value, there are many solutions to an inequality statement. So we can represent those solutions with a graph. That's what is our learning target for today. Learning target. Let's write that down as well. I can graph the solution set of a one variable inequality. Being really precise with the language because it kind of helps kind of unpack the ideas. We're just looking at one variable and how it compares to a value and trying to graph that. So let's look at a couple examples. Let's say we're looking at the inequality statement h is less than or equal to, right? That's what that symbol means, the little line underneath, or equal to -3. Interesting. Starting off with a variable being less than a negative number. But let's just kind of unpack this and it'll make sense, I hope, as we go through the solution. So we kind of give ourselves a blank canvas being the number line, and then just kind of put the value you see in the inequality statement somewhere in the middle. And then maybe every 2 units we'll go over -1, right as you go left on the number line, or I guess this is backwards in the camera. Left on the number line, it's more negative. Right on the number line, everything becomes more positive. So let's continue to just create the number line where we'll graph our solution set. Because as we look at this, we can start to think about what are and aren't solutions, right? Like let h be -5. Is that a solution? Well, is -5 less than -3? Yes, it's to the left on the number line, right? It's sort of over here. And so that would be a solution. Is that a solution? Yes. Because -5 is less than, -3. Okay, so in fact, everything to the left of -3 on the number line is a solution. That's sort of the conclusion we can draw from kind of that thinking of just imagining a value that's to the left of -3 on the number line. But what about, is -3 a solution to the inequality statement? Think about that for a second. Like, is -3 less than or equal to -3? Well, as you say it out loud, is -3 less than or equal to -3? Sort of presents itself to you. Less than or equal to -3. It's equal. So yes. And so like how do we represent that, right? We have the solution set to this inequality statement, h is less than or equal to -3, is -3 and all the values to the left of -3 and all the values. So it includes that -3 mark. That's where we need kind of new symbols. So maybe you've seen notation where you use a closed dot. We're going to use this little symbol means includes the end point or value. That's what this little symbol means. So let me pick out a different color pen. I think that would be helpful. And then it will say, okay, our solution set, if we were to graph it on this number line, it's going to include that -3. So I kind of create this, like, I don't know, this is like beefy bracket here. And then all the values to the left on the number line of the solution set. All the values to the left of our solution set. Cool. So that's one example of graphing a one variable inequality. But I feel like this lesson were incomplete if we didn't do a couple more. So let's look at 2 more examples of graphing an inequality before you'll get some practice. So a quick note. All right, we have 4 inequality symbols. This guy, this guy, this guy, and this guy. I just want to clarify what those mean. So feel free to skip this part if it's like totally review, but get these down in your notes if, because I think reading each inequality statement is just as important as being able to kind of visualize what values satisfy the inequality statement. So let's look at what each of these mean. This symbol is less than. So this would be x is less than 3, greater than, and even if, maybe we get comfortable with maybe we have -5 is greater than p, right? So the variable can be on the right side of the inequality statement. It still reads the same. You can read it left to right. Like this would read, this one here, for example, would be -5 is greater than p, and p is less than -5, right? So whether you read it left to right, it has the same mathematical meaning. It's consistent. It's very cool. This symbol is greater than or equal to, right? Like the example we graphed above. It's not greater than or equal to. It's less than or equal to. Get it together. Get a grip, man. Less than or equal to. And this one is greater than or equal to. We'll say C above. And this one greater than or equal to. Maybe an example would be, I don't know, N is greater than or equal to 4. So these are examples. But let's graph a couple more examples. Let's say we have the statement graph the inequality x is greater than 0. X is greater than 0. Basically, x is every positive number. What would that look like on a number line? So let's create our number line. Blank canvas. In the middle, let's put 0. And all the values to the right will be positive, 1, 2, 3, etc. To the left, -1, -2, and -3. Now notice this statement is not a or equal to statement. So 0 will not be included in the solution set. So we're to graph x is greater than 0. We need this little symbol, this symbol. And this will make sense when we introduce interval notation, why we're using these symbols instead of open and closed dots. So this means does not include the value. But gosh, does it get close. At point 0.0000001 still is greater than 0. even the smallest, the tiniest of numbers greater than 0 is still greater than 0. Epsilon, for example, would be greater than 0. So how would this graph look? Well, you'd use this new symbol, the kind of soft or curved bracket, not the angular kind of rectangular bracket, and then everything to the right, all the positive numbers on the number line. Boom, just like that. Cool. And last example. We'll wrap it up. Last example. Let's graph the statement. I like this one. -3 is less than p. So this reads, -3 is less than p. Right? So p needs to be, I kind of think about that in reverse. -3 is less than p. Right? So one might think, is this numbers that are less than -3 or greater than -3? But -3 needs to be less than the value p. So here's the question. Is 0 a solution? Yes, because this is a negative number. So yeah, of course, p is greater than 3. -3 is less than 0. So let's give ourselves a number line. We've made sense of it. So let's kind of keep doing the same thing. Have -3 be kind of where we start graphing. -1, 0, 1, -4, -5, -6, and -7. So p is greater than, this number line represents the values of p that are the solution of this inequality. So again, now kind of learning a new form, we're going to be using a curvy bracket, right? This is a strict inequality. -3 is less than p. It's a strict inequality. So that means p is greater than -3. P is greater than -3, right? And so that comes out of just being able to read these statements. You're not looking for the inequality statement to be an arrow, kind of do away with that old habit. Instead, just think of how you'd read the statement, and that'll typically tell you how to graph it. Okay, and that's going to wrap up this video lesson on graphing one variable inequalities. Thank you so much for watching. Take care. Bye-bye.